Okay, Unit 7, Lesson 2. This is the area model for multiplication, where we're going to be looking at partial products via the rectangular sections model, and that'll talk about how we can break apart a multiplication problem that is using two-digit multiplication to make it a little simpler for you to solve the problems. You need your student activity book, page 265 through 266. So go ahead and get that out if you don't have it out already. All right, up at the top here, these are some mental math problems. You guys don't have those on your book, but please recognize that when we're talking about these numbers, it's like yesterday's lesson talking about the shifts and the multiples of 10 and 100. So if you start with 6 times 3, which is 18, and then you look at 60 times 30, it's just adding those two zeros on, or 60 times 300, right? Add 3 zeros on because there are 3 zeros in the original equation, so you want to put them there in the product. So it's kind of that shift that we were doing the other day. So when we think about rectangular sections, we can think about area. When you think about area, you think things like 43 times 67, an area type problem would look like this over here. But that could be pretty difficult to do. Those are fairly large numbers. They're odd numbers. That makes it even more challenging. So if that was challenging to you, you can break that up into rectangular sections. When you break it up into rectangular sections, what you're really doing is you're taking these larger numbers and you're making them into smaller pieces, smaller parts or partial products, so that you can multiply more quickly, more easily. This problem number 1 here is a rectangular sections problem where they've taken 43 times 67 and broken that apart into 40 times 60, 7 times 40, 3 times 7, and 3 times 60, all respectively. And so you find the product of each of those smaller multiplication problems, and then you add the sum of them all together. So that's how we would explain it down here on this answer line of what you're doing, right? You're finding the products of the smaller parts, and then you're adding those products up together to find the total sum. Okay, so let's give that a shot here with 39 times 54. I want you to use example 1. I want you to pause the video and practice that. See how it goes for you. Try the rectangular method first, okay, and then play the video and see how you did. Okay? All right, welcome back. So we're doing 39, right, times 54. And it doesn't matter if you guys did yours the other way. Oops, this is 50 and 4, right? If you put 54 across the top, that's fine. Either way. This is like a multiplication box, the factor puzzles that we've done in the past. You want to bring those numbers over and across and down. Okay? Then in this largest box, we're doing 50 times 30. 50 times 30, you could think of it as 5 times 3, which is a little bit simpler, and then adding back on those zeros. So 1,000, right, 500. Okay, 9 times 50, again, think about 9 times 4, so that you've got 45, and then add that 0 back on. Okay, 9 times 4, 36. Hopefully you've got that mental math down. And since we did that already, we know that 4 times 30, 4 times 30, 12. Add that 0 back on. Okay? Then you would add all of those up. 1,500 plus 450, okay, plus 120 plus 36. Okay, we need to show our work when doing that, but when you get the sum of that, you would have 2,106. Okay, so the sum of all those products equals 2,106. Let's go ahead and turn the page, look at the next page. Expanded notation, right? And it's just a different way to look at how we multiply. Okay, so we'll talk about how that is similar and different from the rectangular method. I want you to actually try and answer number 3 as a discussion question. See what your ideas are. So you'll have to leave this and go to the discussion questions when you're finished with the lesson. And I want you to talk about these methods, what the similarities and differences are. ACE got the expanded notation. You'll notice that they just broke apart the number. There's no picture to model it. B is probably the what I call the traditional multiplication. It's just straight multiplication. It's probably how your parents learned to multiply. And then the other model is the rectangular method model. And I want you guys to go ahead and choose whatever method you would like from above. Try them out on problems 5 and 6. On problem 5, you are multiplying 32 cows on the car today, and each car will hold 28 cows. So 32 cars times 28 cows, okay? And then on number 6, you're multiplying 21 times 52 because Maria jogs 21 miles every week and there are 52 weeks in a year. So pause the video quick and see what you get with that, okay? And then come right back. All right, welcome back. Hopefully you have solved these problems with whatever method you chose. There are 896 cows on that there train today, right? If you broke this apart into the rectangular method, you probably would have done 30 up here, then a 2, 28, and, so 20 and 8, right? And then solved for that. Whichever method works for you is fine with me. Then down below here, when we did 21 times 52, you should get 1,092. And again, if you did this rectangular method, you may have put 50 here, brought that 2 on over here, done 20 here, and 1 here. Okay? And again, you just carry all those numbers over. So, we will do more of this at school where you will complete your homework page. Hopefully you were understanding that. If not, rewatch the video, and as soon as you're finished here, make sure you go do your discussion question on how these methods are similar and different.